Hi everyone. So I'm going to go through number 44 from the AP Test Prep in Chapter 8. This is a great problem because in this question we're looking at an inelastic collision that's not perfectly inelastic. So we're looking at some energy being lost, so we're not able to use the conservation of momentum and conservation of energy equations together as a whole on this one. We actually sort of use them against each other. So let me go ahead and go through this one for you. So this one, it says mass A is moving with an initial velocity of 15 meters per second in the positive x direction. So mass A, and it says that its mass is 2 kilograms. And its initial velocity is 15 meters per second. And it collides with mass B, and it says it's moving in the positive x direction. The other one is moving in the positive x direction as well. So we don't have to worry too much about direction on this one. So then we have mass B, and that is equal to 4 kilograms. And its velocity is 7 meters per second. Then it says, after the collision, the two objects stick together and move as one. So MA plus MB is going to be equal to 6 kilograms. And then our VF, our final velocity, we don't have to worry about anything, or I'll just call it V prime to keep it consistent, but we don't have to put an A or a B underneath it because they are stuck together, so they have the same velocity. We don't know that. And then it says, what is the change in kinetic energy of the system as a result of the collision? Well, we know how to figure out the change in kinetic energy, right? So we would do 1/2 MAVA squared plus 1/2 MBVB squared does not equal VF because we know that it's changing, right? So this is going to equal our kinetic energy initial. And because this is, everything's combined, we can say 1/2 MA plus MB times V prime squared equals the kinetic energy final. But we don't know V prime, so that's our starting point. We need to find that. We can find that using our conservation of momentum equation. So we've got MA VA plus MB VB equals MA plus MB times V prime. So then we can divide both sides by MA plus MB divided by MA plus MB divided by MA plus MB. So we get MAVA over MA plus MB plus MBVB divided by MA plus MB equals V prime. Now, I don't know why I didn't just keep this all as one numerator with one denominator, but it works either way. So don't worry too much about it if you just did MAVA plus MBVB all over MA plus MB. That's probably a better way to do it, but I've gone this far, so I'm going to stick with it at this point so I don't have to rewrite everything. All right, so we've got MA, which is 2 times VA, which is 15, divided by 6, plus MB, which is 4, times 7, divided by 6. That equals 9.67 meters per second. Now I have everything I need to plug into both of these. So I will start with my initial kinetic energy, which is going to be 1/2 times 2 times 15 squared plus 1/2 times 4 times 7 squared equals 323 joules. And then my final kinetic energy is 1/2 times 3. No, that's, I already did it in my head. So 3 times V prime 9.67 squared equals 280. We'll say 281 joules so that I've rounded properly. So then my delta kinetic energy is KEF minus KE. That's a little EI. So 281 minus 323 equals -42 joules. Okay, so that is our change in kinetic energy. The system loses 42 joules of energy by going through this collision. All right, thanks.